All right. We're going to do 1.4 today, which is just kind of an extension of what we did in the last couple assignments. So, for instance, problem 1 asks us to factor. Can you think of two numbers that multiply to be 81 and add to be 18? 9 and 9. So x plus 9 and x plus 9. If it asked you to find the roots, what would they be? Would just be negative 9 and negative 9. How can we have two roots in the same place? Well, if I draw a parabola, oh, it's negative 9, sorry. So if I draw a parabola that looks like this, you can see that it has two roots. And if I were to move that parabola up, that doesn't have any real roots. It actually does have roots, they just involve imaginary numbers. But there's this spot between two roots and no roots where those two roots get closer and closer together until they meet. And when that happens, we have a single root right there. So if a quadratic equation has a duplicate set of roots, then that is a parabola that bounces off the x-axis at that number. Okay. The next one's a little bit weird. So I'm going to treat this like u squared plus 0u minus 9. Can you think of two factors that multiply to be negative 9 and add to be 0? U plus 3 and u minus 3. Okay. What if I asked you what the solutions were? What would you tell me? U is equal to negative 3 and positive 3, or a lot of times we just say plus or minus 3. Okay. Now, these factors have special names. They're called conjugates. And conjugates are factors that look the same, except they have a different sign between them. Whenever that happens, you will end up with a middle term that's 0, because the positive 3 and the negative 3 fight each other and they kind of just delete each other. Then we're left with something like this. That quadratic is referred to as a difference of perfect squares. It's u times u and 3 times 3, and it has to be a subtraction. If it's an addition, then it's not going to factor. Okay? So if you have a difference of perfect squares, it factors into conjugates. Okay. Now, number 3 looks really difficult, but notice we have a missing term in the middle. This is a difference of perfect squares. What two values multiply together to be 64v squared? 8v and 8v. So this is 8v and 8v. What two numbers multiply to be 49? 7 and 7. And I have a subtraction. Remember, it has to be a subtraction or it won't work. So it looks like that. Do you guys understand that? Okay. What about number 4? Is it a difference of perfect squares? Yeah. 7y and 9z. So this will be 7y plus 9z and 7y minus 9z. Okay. Number 5, you factor normally. Okay. Look at number 10. Number 10 is missing a middle term. Right? There's no middle term. But is it a difference of perfect squares? Is 2x squared y squared a perfect square? No. Is 72x to the fourth a perfect square? No. So we need to look and see, does anything factor out? And we find that it does. So what can I take out of both terms? 2x squared. So I'm going to grab the 2x squared and pull it out. Grab a 2x squared and pull it out. And I get 2x squared. And then I'm left with y squared minus 36x squared. You guys follow that? Okay. Now I have a difference of perfect squares. The 2x squared stays. And I get y minus 6x and y plus 6x. Do you guys understand that? Yeah? Do you need to see another one, or do you think you can handle it? Another one? Let's see if I got another one on here. If not, I'll just build one. Okay. Number 15. 75 is not a perfect square, but I can take out 3y squared. 75 divided by 3 is 25 with a y squared minus 4. Is that now a difference of perfect squares? Yep. So 3y squared, 5y minus 2, and 5y plus 2. Does that help? Okay. Get to work.